Alrighty, everybody. Good afternoon. Today we have session number 4. So we're going to be talking about fireworks both at the network level, but also at the host level. So a few different strategies that you can use, at least in terms of our competition defense strategies. This is typically the first thing that we can do. It's not necessarily a silver bullet, but at the very least, in terms of giving yourself a chance to go ahead and set up additional hardening to take a further look at other areas of interest that potentially are either backdoors or other mechanisms that the red team might be able to use to gain access to your systems. This is a great place to at least start. And generally speaking, you don't want to just ignore them. There are different ways in which maybe there could be different rules and exceptions that get added in over time, and sometimes we lose track of those. And that's kind of one of the issues with firewalls in some cases, is that we like to just kind of, oh, well, this makes our job a little bit harder in terms of our engineering jobs. And so sometimes we may go ahead and just keep adding exceptions, not noting that that then makes it a little bit more vulnerable. So, but at least in terms of a competition strategy, this is a very good point where you can go ahead and get started with that. It gives you some extra breathing room and extra time in order to set up some more involved and active defenses. At least in terms of where we're at right now, at least in terms of the overall cyber defense bootcamp, we've gone through the first session so far. So we're in the home stretch here. We're starting to reach toward the end here. Up until now, we looked at different command line tools that we might be able to use, different command line commands that are very important. We took a look at how to set up a very simple network with Ubuntu, CentOS, and Debian machines. We installed a few different softwares, specifically SSH, FTP, and then HTTP within our own environment. And then yesterday we took a look at some things from the red team perspective. So we took a look at different tools and different techniques that a red teamer might be using from an external point of view to gain access. So, and then of course today we're doing some stuff with firewalls. A little bit of a refresher, at least in terms of what our network topology looks like. We have given you access to 6 machines. So we have 2 Kali Linux machines. We have an external machine and an internal machine, and we'll get to use both of those today, at least in order to kind of take a look at how different things can look at from where you are within the network. Then we have 2 CentOS machines. We're actually going to start with that router today, and then we'll pivot over to the website. And then finally, we have an Ubuntu and a Debian machine. Both of those have a few various different things that we'll be taking a look at today. A little bit, at least in terms of before we begin, first, I do want to kind of highlight 2 tools that at the very least internally you can take a look at and see what different ports are listening and open on your machines. So at least for our CentOS machines, it does not have netstat installed. It has SS installed instead. And then on the Debian and Ubuntu machines, we're going to be using netstat. You can install netstat on that CentOS machine. I think you can install, I think it's called NetTools, but at the very least in terms of today, we'll be using SS. And I'll very quickly kind of show you how we do that. So let's go ahead and take a look. I'll go ahead and pop open our environment here. At least in terms of today, I would highly recommend go ahead and just turn all 6 of your machines on. We'll be using each of them. We may use them lightly, so we may not use them extensively. We may just kind of be popping around, but at the very least for today, we'll just kind of briefly take a look at each of these. So if I go ahead and jump into one of our CentOS machines, so if I take a look at this is on the router here. As I mentioned, we can go ahead and start with the SS command, and we see what services are currently listening on the devices. So if we go ahead and take a look, we have, I believe port 68 is related to DHCP. So in this case, it is checking to see what IP address it has been given from the DHCP server. If I do an IPA on this, we can go ahead and see that we are given an IP address here on ETH0 of 10.0.10.47. And then we also set up that static IP address earlier as well. All right. And then other than that, we see it has SSH open on port 22. And then on port 25, there is a mail server that, at least in terms of more recent CentOS installations and distributions, they seem to like to have that on there by default. In terms of that netstat command, we can go ahead and pop on over to, let's say, the Ubuntu machine, so the Ubuntu workstation. We'll go ahead and open that up for us. So if I go ahead and make that, we'll go ahead and log in as root on this machine as well. And then we'll run netstat. So I don't know if maybe I put the password in incorrectly there. Give it a sec. Let's see. Well, it's running a little slow today. I'm not entirely sure why. But at the very least, maybe I can jump on over to the let's see what that one's got going. Go ahead and jump on over. So if I go ahead and take a look at that, let's see. Alrighty, so the Debian machine, we'll go ahead and make that full screen real quick here. So we'll log in as root, and then the password is root, and then we'll go ahead and run a netstat as soon as it's ready. So they're all running a little bit slow today, not entirely sure what the issue is, but and this one, netstat. Did I spell that right? Yes, it did. Netstat is also. On other ones, I found that it has netstat on it, but I guess today we didn't. Alrighty, so we have a few different things running. At least in this case, we have the bind DNS server on 53. Typically, if you see some other ones, there's some various other processes that are running that you may need to do a little bit more investigation on to kind of determine what they are. So let's go ahead. I did say that we would take a look at Ubuntu. In the past, I've used netstat with Debian. I'm not entirely sure what the reason was for that, at least for why that would have SS on that. So if we go ahead and run that, make that full screen. And on this one, for our Ubuntu machine, this one we use netstat, and then we see both our FTP server and our SSH server. So I wanted to make a note of that as just something that you can use to go ahead and check to see what's currently listening on your devices. If there are current active connections, that's another good way to do it. So if I were to jump on over to the internal Kali Linux machine, so let's go ahead and take a look at that. So go ahead and take a look. Oops. Oh, come on, there we go. So if I go ahead and log in on my Kali Linux machine, I don't remember what the password for that SSH server was, so I may play around with that. Oh, you know what? Actually, we used the private key on that one. So let's see, SSH David at 192.168.0. I believe it's 3. I believe it's ABC 123. Oh, there we go. It's just 123. As we can see, I've logged in. So if I hop on over back over to the Ubuntu machine, go ahead and make this full screen again, and I run the netstat command again. This time we will see a current connection, established connection between the workstation, which is .3, and the Kali Linux machine, which is .5. So as we can see, not only does it show things that are listening, but also things that are currently connected and established between those. So that's just a good tool to get you started with for later. And we'll talk more about that next week when we take a look at hardening and different techniques that we can use in terms of hunting things down. Alrighty, so as I mentioned, we're going to go ahead and get started with a network-based firewall. So if we go ahead and take a look back at our network diagram, we're going to be focusing on this CentOS router. So we're going to figure out different ways in which we can protect our internal machines. Typically, we don't want someone externally to be able to internally address these. Now, since we only have masquerade set on the external zone for this CentOS, and we'll show you that in a minute. But since we only have masquerade set on the external zone, we can't actually address these from externally. So if I were to try from this external Kali Linux machine, and we'll go ahead and open him up as well. So if I go ahead and pull that one out. So if we go ahead and take a look, we're actually going to do scaling mode here. Let's see if that works. There we go. In this case, we're not able to directly address those internal machines. So if I go ahead and try and do a ping real quick, and we're also not using our CentOS machine as our gateway either for this. So as we can see, we don't get this ping doesn't resolve, and that would make sense. So if I consider it this machine only knows the network from here. So it only knows it on this /16 CIDR network. It only knows this network here. And that makes sense. But we want to be able to actually access and use those inner services from our machines. So if I go ahead and head back out to our slides, let's go ahead and talk a little bit about that. So when we were setting up our router, and also when we were setting up our website, we did a little bit with Firewall-cmd. And it's just another command line utility for firewalls and interfaces. We'll take a look at least in terms of the host-based ones, we'll take a look at two tools. We'll take a look at Iptables and then UFW. And all we really need to do is we can go ahead and take a look at what zones are set up. And in our case, for our CentOS machine, we did two main zones. We did the external zone. So if I do Firewall-cmd, list all zones, we just get everything. And that's not as useful because some of it gets cut off, at least by the screen. So if I go back, CMD, list all zone equals external. So if we go ahead and pop that on open, we can see here that we have set ETH0, which is our external facing interface. And that currently has SSH and masquerade set. Essentially what that allows us to do is from the internal zone, we're able to then access the internet essentially. And then we also have list all zone equals internal. And we see here, we see a few different things here. You see Ethernet 1, so that's our internal one. And there's a few different things that it automatically allows. So for instance, it allows us to SSH into this server. There's a few things with Samba and then THCP v6. But we also note that masquerade is set to no. Alrighty. We can also control the interfaces in which zone. So in this case, we could either use the Firewall-cmd command to switch those zones. I forget what the exact command was. We did it when we were setting up the router. But if I go ahead and take a look at my systems, let's see. Oh, sysconfig, I'm sorry. The etc sysconfig, network scripts. So, if I go ahead, we'll do read only. As we can see here, it's gone ahead and it put zone equals external. So as we can see here, that's all good to go for us. At least in terms of our different options, so we have internal, external. Masquerade allows us to forward traffic across the zone. But at least in terms of how do we make it so that we can externally access something from the inside, we're going to go ahead and use something known as port forwarding. So rather than directly contacting those servers, and in a way it's just forwarding the traffic over, rather than having to address 192.168, maybe we only want to address that CentOS router. So for instance, let's go ahead and let's set it up for the FTP and HTTP. We can do it for SSH, but again, when we went back and we set that up on that SSH server, we set it up to require a public key in order to communicate. So in our case, even if we were to set up SSH, we would need to then move on and actually set up those keys for us in order to get that to work. So we'll go ahead and at least today, we'll focus on just FTP and HTTP. So if I go ahead, and before we do that, I'm actually going to quickly do an Nmap scan. So yesterday we took a look at how to do a quick scan of a target machine. So if I do Nmap -bn-a-v 10.0.10.47, this is the machine that we're doing stuff on here. In this case, we see a port open for 22. If I were to SSH onto this machine, it would be for the CentOS router. Other than that, there are not going to be any ports that are going to be exposed from this side. So if I go ahead and take a look at my router, we're back here. I'm going to use a little bit of a cheat sheet here to make sure that I get the command right when I'm printing it out onto the screen for everybody. So if I go ahead and take a look, we're going to go ahead. I'll clear the screen real quick. We're going to do Firewall-cmd. The zone is going to be external. Oops, apologies. We're going to go ahead and add --add forward port. And in this case, we're going to do, add forward port equals 21. So we want to do FTP. Proto equals TCP:2 port equals 21. to address equals 192.168, oops, .0.3. So I'll just kind of run through that. So we have add forward port. The port is equal to 21. Proto equals to TCP. I'm not entirely sure what that line means, but at least in this case, to port, this is the target. So in this case, we want to send it to port 21, and we want to send it to 192.168.0.3. So we went ahead and did that. I can go ahead and add -- permanent as well. So we can go ahead and do that, and then we just reload the file. Go ahead and reload. Now, if I go ahead and I take a look at what the Firewall-cmd says, oops, I spelled Firewall-cmd wrong, forgot the E. We go ahead and we see this forward ports here. So we go ahead and we see these forward ports. And now if we go ahead and do the same Nmap scan on the target, we see this port 21 has shown up here. So if I go ahead and I open up another shell and I do FTP, I believe I have to give a user, I'm going to try David 10.47. It's going to go ahead and require my password for my FTP server. I want to say I did David. It could also be ABC123. Yeah, login successful. And here we are. So we've gone ahead and we've made it. These are the two directories that we had before. We had this pictures directory. Go ahead and take a look in here. We had this temp.txt, and we've made it onto that internal FTP server. We're able to access it with this 10.0.10.47. We don't have to expose any other ports on that internal machine. It's just the port 21. That's the only thing we want to be able to see from the outside. And so that's why we're going to use it. So we're going to go ahead and do that from there. And as we can see, we're gaining information. We see that on port 21, it's a VSFTPD, and on port 22, it is some sort of OpenSSH. Now, as you may guess, we're actually able to change this. So if, let's say we wanted this to be 1234. So let's say rather than addressing port 21, and we still want this to say to port. So on the internal server, on that VSFTPD server, we know that it's still serving on port 21. So this here still has to say port 21. But we can go ahead and we can reload this, and it'll still say, we did not remove that initial rule. So if I were to go ahead and do another Nmap scan on the target, if I were to go ahead and do this again, let's see, that's the wrong one. That's the wrong tab as well. So if I were to do the Nmap scan again, it would still say 21. That 21 hasn't changed. And then since it's still checking it, I don't know if it actually normally checks 1, 2, 3, 4. I may have to expand that search. But if I do, let me actually double check how to change the port -P. So FTP -P 1234, David at 10.0.10.47. And as we see, we're still able to get in. And so we can change the port that it's listening on. We could do to port 21, 1, 2, 3, 4. You have your own choice in terms of what you do here. So that's just as a note that I wanted to specify there, at least in terms of other ways in which you could use it. I guess for some reason, let's see. This is having a little bit of trouble here, at least in terms of on that port 22 for some, or that port 1, 2, 3, 4. Let's see. Is LS still working? It's running a little slow. I'm not entirely sure why. Oh, it's probably because of the Nmap scan, if I had to guess. But we also see 1, 2, 3, 4 has that VSTP on there as well. I can also do the website. So if I go ahead and set the website, so if I go ahead and add another one. So in this case, we're going to do port 80. So port 80. We're going to swap this to port 80. And then we're going to change this to 2. And then we're going to go ahead and reload. There we go. And we can go ahead and take a look there as well. So we can go ahead and we'll run the nmap scan again. And as we can see, the port 80 is now going to show up. And we can go ahead and visit it. So we can go ahead and head on over. And we can go ahead and take a look at it there. So if we go ahead and take a look at 10.0.10.47, it just says hello. So at least in this case, we've gone ahead and we've added our forward ports. We have a little bit more control in this case over where we're sending the data. I do want to note, so in this case, if we go ahead and take a look at our Firewall-cmd, we can also use Firewall-cmd as sort of a Firewall-cmd list all zone equals external. As we note here, so we see this services is SSH. So this is the SSH for this machine. We can also set up sort of a host-based firewall here as well. And so if I wanted to remove this, let me just a little bit, remove service equals SSH. Oops, I got to give it zone equals external. And then we double check it. In this case, now if we do ahead and take a look at it, now we can't just SSH directly into that CentOS machine. So in some cases, this can also be used as a host-based one as well. So we've controlled which services are being able to view. So now that port 22 is gone. And now the only things that are accessible here are 80, 21, and 1234. And these are all port forwards. They're just going to one of the machines that's internally within the network. So that's really all I have, at least in terms of that network-based firewall. That's the main thing, at least from a competition perspective. That's the main thing that you'll be using this for, at least from a network-based sense, is using it for that port forwarding purposes. So you don't want somebody to be directly addressing those internal machines. You want to limit as much as possible the attack surface that someone's going to be able to use on your network. You just want them to check out that CentOS router, only address that, and then you also want to make sure that it's not exposed either. So in this case, we went ahead and we turned off 22 on it. So even though they see these 3 ports that are open and listening on the target, it's not actually on that CentOS router. So that's just as a note there that I wanted to make a highlight there as well. So if we go ahead and next, and we're going to go ahead and take a look at host-based firewalls. This is then going to give you additional protection for the machines on the inside of the network. So even though we set up the network-based guy that's going to be filtering traffic and making sure that, okay, we're only going to be able to you're not directly interfacing with those internal guys, you're only going through that port forward. Now we want to go ahead and add some internal protection, because in theory, let's say somebody does break into one of the internal machines. You want to make sure that they're not then able to cause any more mayhem internally. So to do that, I'm actually going to go ahead and I may need to actually stop using my DNS. Let's see. I'm going to go ahead and install a few things. It's mainly we're just going to install an additional app install HTTP. Let's see. Let's see, apt install Apache 2. So we're just going to quickly install an Apache 2 website. So we'll go ahead and install that. So if I were to do netstat now, we can go ahead and see that now we have a website that's running on here. And this is just to show that we could go ahead and we can kind of limit some of that, what's allowed. So if I do netstat and view, we see 22. I guess we still have that SSH connection. Then we have 21, which is our FTP server, but we also have a website. I don't believe the website has anything. It may just be the default page. So if I go internally and I go ahead and address the page, let's go ahead and take a look. So we'll go ahead and give that a sec to run there. And of course, if I do a nmap scan, it'll show there as well. So if I do 192.168.0.3, it's just a default page. So we see a default page here. If I go ahead and I take a look at my nmap scan, and blow this up a little bit, nmap -pn -t4-a -v 192.0.3. And I could, we're still resolving to that DNS server. So if I wanted to, I could, but we see 80, 21, and 22. Now, at least in terms of the setup that we have, the only two ports that we want to be accessible externally are going to be that 21 and 22. So we want to make it so that that 80 doesn't show up. There could be any valid reason. So for instance, let's say that I set up a MySQL server. So let's see, apt install MySQL. Oops. Maybe this server. Let's see. Yeah, we'll go ahead and do that. Go ahead and install a MySQL server. So there could be something where, let's say that we're running something and we need to have a MySQL server. And in a lot of cases, that'll be listening internally on the loopback address on 127.0.0.1. And you don't want that then to be exposed to the outside world either, but you still need it to be running locally in order to access that database to update some information or whatnot. So you still need it to be running, but you don't want it to be just sitting there available to other people to go ahead and access. So we'll let that run for a second here. It's running. Let's see. I think it's just setting it up. So we'll give it a second here. It's setting up a SYN link. And it's at 99%. And let's do our netstat real quick and see if we can see it. Now, it may already just set it on the loopback only. So in this case, we won't see it with the nmap, and I'll have to do a little bit of configuration to make sure that that it works properly. So netstat and do. Let's see. So yes, so that just did it on the loopback. I'll have to do a little bit of searching real quick. Let's see, Vim, or let's try nano, etc, MySQL maybe. Conf.b. It's a directory, my apologies. MySQL.cnf. Doesn't have anything in it. We're just gonna kind of look around here real quick and let's see if we can find anything to quickly set that up. If not, we won't go too far in it. MySQL.cnf. Let's see, that's not going to do anything. Let's see. Or let's try MySQL conf. No. That doesn't have anything in it. And we're just kind of riffing here a little bit. We're not, this is just to kind of add additional. So it's most likely in this MySQL conf.b directory. Oops. Keep putting a space accidentally with the, no, okay, that's interesting. There we go. Okay, there we go. So in this case, instead of saying the bind address as 127, we're going to go ahead and change this to our address. I believe you could also do 0. So if I do 0.0.0.0, I believe that would also work as well. But I'm just going to give my address. So it's 168.0.3, 192.168.0.3. I'm going to go ahead and write out, and then we'll just restart systemctl, restart MySQL. So this, MySQL-D. It's probably MySQL-D. Oh, I spelled MySQL wrong. That would be why. There we go. So we'll let that run real quick and we'll see if we can, there we go. And if I do a netstat now, we should now see on, let's see. There we go. We should now see that on 3306, MySQL is now running. And then if I were to go back over to my Kali Linux machine, we could then see it there as well. So if I go ahead and do the net stat again, now 3306. So we've given ourselves more stuff that we can go ahead and check against it from there. So we go ahead and let that run, and we see, yes, MySQL is now there. So at least in terms of how we're going to protect this, we've got two different options that we could choose. At least in terms of kind of what we found is kind of at least the good introductory way to do it. There's other, I mean, there's tons of different firewalls that you can go ahead and use. There's all sorts of open source ones. In the previous year, with especially with the NCA cyber games, what we ended up finding was they actually disabled IP tables in UFW, and we found a different one that we could use. I forget what it was called, but at the very least, if you understand how to use IP tables, you understand how to use UFW, you should be able to then quickly pick up another one, figure out what the syntax of it looks like, and you should be able to achieve the same effect. So Iptables is a simple command line tool for controlling the flow of the packets. So we can go ahead and check our current configuration with an Iptables-L. So if I go ahead and find my Ubuntu machine, Iptables, I'm going to go back to my root, Iptables-L. And we see, and it's very permissive initially. So we see the input chain. So this is any incoming traffic. We see the output chain, which is any outgoing traffic. You may see forward stuff if you're dealing with some sort of Docker container. So if you've got a Docker container, you may find that it's forwarding it to something internally with that Docker container. But as we can see here, it's all by default set to be accept. So it's very permissive. We're still able to contact everything. Everything's all good. It'll let everything go through. If we want to go ahead and change that, I prefer a policy. So in this case, the policy in this case is going to be to drop. So if I do Iptables -- policy input drop, and then we'll do the same thing with forward, and then we'll do the same thing with output. So if I go ahead and take a look at my policy, at my policies now, they all say drop. And we'll see a very similar thing on the Kali side. So if I go ahead and I rerun the command, you'll find that it can't see anything anymore. The website's gone. If I try and reload it, it's going to hang. It's not going to find it anymore. So we've succeeded in blocking all traffic. Something that we found, at least with CCDC, is that one thing that they like to do is that they will just drop all the traffic. That's the first thing that they'll do. So if they happen to get on your machine, they'll drop your traffic and see, okay, are they going to figure out that we haven't really done too much? We've just dropped all traffic, and we're going to see how they respond to that. Because practically speaking, from a scoring perspective, if you just drop all the traffic, it's the same thing as turning off the service. It's the same thing as completely wrecking your box. And they want to test you and see, okay, how do you respond to that? Do you realize that something has gone wrong? And you're going to learn a lot more that way. You're going to learn, okay, they turned it all off, and now we want to go in and we want to check the logs and see, okay, how did they get on the machine? That's going to be a lot better of a learning experience than just wrecking your machine and making sure that nothing works anymore. So that's typically, at least what we found, is one of the things that they tend to do right away, is that they'll just set your drop all your traffic, they'll flush your rules, and then it's up to you to figure out, okay, something happened there. It's not all lost, so you can fix that, then go ahead and do more investigation to figure out what went wrong. So that's at least a good start. So we've gone ahead and we've dropped everything. What we can do is we can actually set allowing specific IP addresses. Personally, I don't do this very frequently. It could be used in some specific circumstances. If maybe there's like some sort of login that you need, it has to be there, and for whatever service that you have is the only way it's going to work, and you want to very specifically allow a specific IP address to do it. It can be used. But again, it's not a silver bullet. Even if you say, okay, only a specific server can contact this other one, that there are workarounds to that. If they got on to that machine, then they can try and pivot It's not the best way to do it, but I can quickly show this here. So for instance, if we go ahead and use this rule set, so we'll go ahead and pop onto this, we can go ahead and re-enable something. So let's say that I want to re-enable the search. So in this case, Iptables -A is to append. So we're appending a rule. So Iptable -A, we're appending an input, or let's start with the input. In this case, the input, we're talking about the source. So in this case, the source is going to be that Kali Linux machine. -J is in terms of, I believe, the new rule. And then we're going to do output. And in this case, it's the destination. So we want to send it to. So now if I go ahead and read my rules, we see that we have these two new rules here, and it looks like, yes, the source and destination are correct. So if I jump back over to Kali Linux, we can go ahead and try it again. We can try, that's just a random. We should be able to NBC it again. So we see the website's back. We're able to SSH. So if I SSH into David at 192.168.0.3, it wants the passphrase, which is 123. And it's hanging for a second here, and it's in. So as we can see, we've allowed it on a specific source and destination. Again, that can be used in very specific circumstances. I don't use it very frequently because in some cases. I can go ahead and flush those. So if I go ahead and list again, if you flush it, it still keeps the drop rule though. So it still keeps the drop rule. It just gets rid of the appended rules that you have or those exceptions that you've added in. So that's just one option that we have. Just be mindful whenever you're doing something like that. The more exceptions that you add to these rules, the more unwieldy it gets, the more things can kind of slip through the cracks and you'll miss important kind of hazards and dangers. We'll get back to this one, but at least in most cases, we like to add this related established. So as you can kind of note that most of these services and protocols use TCP for their communication. And so you have the three-way handshake. It's going to go ahead and establish connection. We add this input output CT state or this -M state. We add this because a lot of times that allows us to do either we can then reach out to the internet. We can do all sorts of different other things. So we're going to go ahead and add these two rules. Let's see. And another thing would note is that, so let's say that we add a specific rule. So we're going to go ahead and we'll actually move on here. We'll come back to this. I'll come back to this. It'll be clearer as to why we do this here. But let's say that we go ahead and add a port rule. So let's go ahead and set a, and I meant to say input here. I'll make sure to update the slides before we're done. But we're going to go ahead and we're just going to add a specific rule. So let's go ahead and add a specific rule for FTP and HTTP. So if I go ahead and do Iptables -A input -P TCP D port 21. So in this case, we want the protocol is TCP, the port itself is 21. We want to accept it. Let's do SSH as well. Go ahead and do that. If I go ahead and take a look at my rules, we have those two as our input. Let's go ahead and give it a go. Let's go ahead and try it. FTP David at 192.168.0.3. And as you can see, it hangs. And if I were to try and fix this by saying Iptables -A output -P TCP D port 21. Oops, spelled that wrong. Or in this case, let's say I think -S port should work. -S port. Let's go ahead and give that a go. Let's see if we can still get this to work. And it does work. So in this case, we can say, I'll double check. I'll remove the D port. So actually we'll flush Iptables -F. See, so we'll do, my apologies. So we'll accept the input and then we'll accept the output to S port. And then we'll take a look at it real quick. So that's one way we can do it. So we can either set the S port, ABC 1, 2, 3, and then we just exit. We can either set S port, or if I flush again, I flush the rules, and we do input TCP port 21, and then import TCP port 22. Or if I do this CT state, if I do Iptables -a input or output, I should say, output -m state related established -j accept. So if I go ahead and add that, it'll work the same. So if I go ahead and set this up, it does the same thing. So we can either say, we'll add the CT state. Again, the reason that we add that is for something like a TCP connection where it relies on the three-way handshake. And if I do a netstat, you'll note that this is tied to some random port address or some random port on the target. So we have port 21 on the source, and then on the destination, it's pretty random. So you have to be careful with that. Let's say that we've run into a few things with like network file shares where they use some other protocol where it even on the source on the server, it doesn't even tie to a static or consistent port. It does it to a random one. So we see there. So as we can see, this will work just fine. If I do my nmap, oops. If I do my nmap scan again, I'll just launch another instance, that's fine. Nmap -pn-a d4. We're only going to get 22 and 21. If we refer back, we initially had 80 and 3306, but we've protected ourselves, so we've made it so that only those two are visible, and we're good to go. So that was Iptables. We can also do something with loopback. So if we wanted to, we could do, we could add in the loopback address, so -olo to accept, and we can also save the rules to a file. So let's say that we're in the middle of the competition and they flush the rules, it's just defaults to drop. We can go ahead and restore those rules based on what we had earlier. So we can go ahead and save ourselves some time if we go ahead and set up some backups there to make sure that it's all good to go. And then lastly, we have the uncomplicated firewall. And this actually sits on top of Iptables. So we can go ahead and see, we're actually going to do this on our, let's see, let's do it on the Debian machine. It's a little bit tricky because we are using DNS on this one. So I'm actually going to go ahead and install SSH here real quick. We'll go ahead and install SSH just as a sample here. As a sample just to show, hey, this is still doing, it's actually protecting us a little bit here. So we'll go ahead and quickly install this. There we go, 76%. As it gets a little bit higher there. And I believe this should run UFW, but we'll check. UFW, it does not have UFW. I believe this is, it's going to be, do I have Iptables at least? Oh, that's interesting. Interesting. Okay, well, we'll install it then. We'll install UFW. So we'll go ahead and do that. Give it a sec. Loading, there we go. So the UFW status, verbose. It's inactive. We're going to go ahead and enable it. And now, I do want to know, and I think I actually have to stay start. I think. Yeah, it's already good to go. Or restart, maybe reload. Or status. We'll do status, verbose. See if it's on. It is active. Okay, great. Now, by default, it's actually going to deny all traffic with the exception of pings. There's a way that you can do it, but it will deny incoming traffic. So if I go ahead and I try to do nmap on our DNS server, -a, go ahead and do that. we're actually not going to get anything back. We're not going to get the SSH server. We're not going to get the DNS. It's just going to come back as blank. It may get pings. So if I do ping, we're actually going to get ping back. So we get everything else is black except for ping. So now we got to go in, and it's called uncomplicated firewall because it's fairly simple to use. In order to enable certain traffic, we just say UFW will allow the port number and then the protocol. So in this case, we want to allow, in this case, we'll actually show allow, let's say 53 UDP, because DNS is a UDP protocol. We're going to go ahead and say UFW allow 53 UDP. And we can also say allow SSH as well. So we can allow the name instead of the protocol or the port number as sort of just an easier way to do things. Now with this Nmap scan, it is, I believe in the setup that I have, it's only going to do a TCP check. So in this case, we're only going to see that SSH. But if I were to do NS lookup of web.bootcamp.ilcyberhawks.com, it should still look it up. Uh-oh, it's having problems. It can't find web. Interesting. Uh-oh, what happened here? Let's see if I'm able to visit it with here. So web.bootcamp. So I have to double check on that. If we just do a UFW allow DNS, let's try that. That's probably a little bit safer in order to try. So let's see if we can get that to work. Oh, it's still not. Why are you still having problems? Interesting. Let me check my EPC resolve. Ah, okay, that's interesting. I feel like I set this up, but let's see. Uh-oh. Oh, I have to be root. Okay, so apparently my etc resolve.conf got reset. Not entirely sure what happened there, but I got reset. All we have to do is fix it. So all I have to do is just add it in. And now we do the NS lookup and we get the response. So as we can see, now it's working properly. With Nmap, we could have done the UDP check, but again, that's a little bit more inconsistent, at least from Nmap. So, and it does take longer. So. And then if we wanted to, we can go ahead and just turn those off. So if we say deny on that again, I don't remember if it deletes the rule directly. So if I do UFW status verbose, it should tell me all of the different rules that are set up. There we go. We see a few. So if I say UFW deny 53/UDP, it should say, yeah, and now it says deny, and then we're going to go ahead and say the same thing with DNS. Oh, I spelled that wrong again. There we go, and now it's denying it. It's specifically denying it. So if we go ahead and take a look, we try to run that. If we try to run that check again, it's not going to be able to find it. It's going to fail. So that's at least how we use those simple firewalls. In terms of a competition setting, these are very important to affecting what the red team's able to do at the start. You really limit what they are able to get done and what they're able to do. I do want to note that if we still run netstat, so if I were to go back to the Ubuntu machine, we still see it here. So if I run netstat, everything is still running. And we're going to talk about this when we're doing our system hardening. But if I take a look, the MySQL server is still running on 3306. That HTTP server is still running on port 80. And so there's different ways in which you can kind of exploit that. You could use that to your own advantages. If you were to either somehow get on the machine, you could then remove the firewall rules, and now you have other ways to get access. So it's not, again, it's not the end all be all. It's just a tool that we can use to limit what the footprint looks like from the get-go. So, but that's all that I have for today. It's a little bit, I know this was a much shorter session I'm having, but hopefully this was useful, at least in terms of kind of at least setting up some of our very first um, our very first defenses here for most of our competitions. So hopefully this was interesting, and we'll catch up with you all on Tuesday with system hardening.